Okay, in this next video, we are looking at this topic that is called calculating relative frequency in a contingency table. All right, so a contingency table is basically another name for a two-way table. Okay, I think it's just another name of the same thing. These particular two-way tables have a lot more subdivisions one way than the other. So you'll see that we've got just basically two rows, but each of those rows is split up into 5 different categories, right? So this problem, if we understand it, and that's why I always recommend reading your thing correctly once or even 2 times, it helps you understand exactly what you're looking at. A sample of 348 students at a university is surveyed. These students are classified according to gender, so male or female. It's obviously not being very culturally sensitive to modern times and people who don't identify as one or the other. But anyway, assuming they identify as one or the other, they are also classified according to a major, which is biology, business, engineering, mathematics, or computer science. So 5 different majors, all right? So the results are given in a contingency table below. So you got female here, right? And so this is all the females right here, all in this row. 21 of them are biology, 40 business, 22 engineering, 19 math, 44 computer science. And then the males, 49 biology, 32 business, 45 engineering, 46 mathematics, and computer science is 30. So it says, what is the relative frequency of female students in the sample? So in other words, for this one, how many female students are there divided by how many are there total? So, and relative frequency is another way of saying what's the percentage of female students in the sample, except we aren't going to write it as a percent. We're going to actually leave it as the decimal that it is. Okay, so, and you guys actually know how to do that. We've been changing everything into percents up until now, and now we don't have to, so this is kind of nice. So let's figure out how many females we got, okay? So we got 21, and then we've got 40 plus 40, and then we've got 22, and I'm going to move this over here. Now we've got 19 and 44, plus 19 and 44. All right, so we've got 146 females in this sample. All right, this is obviously a very skewed sample because there are actually more females going to college and completing college now than there are males. So this is not very accurate sample, but it's very possible that this particular group had more men than women. All right, so 146 of those people surveyed are female, and so to find the relative frequency, it's basically what percentage of people in the population were female, and we just won't write it as a percent. So you go 146 divided by 348, and that gives you this big, icky number. That's a decimal, 0.41954. It says round your answer to 2 decimal places. So 2 decimal places puts you right here at this 1. So in order to figure out how to round it, you look to the next number, and the next number is going to tell you either to keep it the same or bring it up. If it's lower than 5, it's telling you to keep it the same. If it's higher than 5, it's telling you to round it up. So this is higher than 5. It's 9. Right? 9 is higher than 5. So we're going to take this, and instead of 0.41, we're going to have 0.42, or 42 hundredths. All right. Here we go. Let's try another one. All right. 294 people are surveyed. People are classified according to political affiliation, Democrat, Republican, or Independent. They're also classified according to opinion on a bill. So a bill is like a piece of legislation or something that they're arguing about. So they're in favor of them passing the bill, they're opposed to them passing the bill, or they don't care. That's what indifferent means. It means you one way or the other, it doesn't matter to you. So the results are given in the contingency table below. So if we look at, of the Democrats, 46 were like, yeah, do it. 18 were saying no. 36 were saying, I don't care. Of the Republicans, 25 were in favor of it, 21 were opposed to it, but 40 were indifferent. And then 20 independents said, yeah. 47 said no. And 41 said, we don't care. All right. So what is the relative frequency of respondents who are indifferent towards the bill? So of all the people, so respondents means everybody, right? How many of them are indifferent? So it's just going to be all these people out of the total number of people. So 36, 40, and 41. So let's figure out how many people that is. 36 plus 40 plus 41. Because those are all the people who are classified as indifferent. It doesn't say in there whether they're Democrat, Republican, or Independent. It's just saying of all of them, right? So there's 117 people who are indifferent. And to figure out the relative frequency, it's divided by the whole. So divided by 294. So I would say that's actually a surprising population or amount of people who are indifferent. All right, round. So you got 0.39. We'll go over to that 7, and that 7 tells us we're going to bump that 9 up to, we're going to turn this 0.39 to 0.40. Right? 0.40. Not 0.490, 0.40. All right, let's check our answer. Way to go, guys. Thanks for sticking with me on this. Let's keep up the good work.